Write the equation in logarithmic form. E to the negative 1/2 equals 0.6065. Let's note that a to the bth power equals c could be written as log base a c equals b, or ln c equals b, where ln is the log base e. Since we have the e as a base, we're going to use the last one, which is log base e c equals b. So, by changing the exponential function into a logarithmic form, we have log base e 0.6065 equals negative 1/2. Now, log e could be written as ln, so we have ln 0.6065 equals negative 1/2. That's the answer. Write the equation in exponential form. Log base 381 equals 4. Note, if you have a log base AB equals C, then you can change the form into exponential form by A to the C equals B. So here we have 3 for A, 81 for B, and 4 is for C. So by using the formula, we have A, which is 3, to the C, which is 4, equals B, which is 81. Write the equation in exponential form. Log base 10, 100,000 equals 5. Let's note that if you have a log base A, B equals C, you can change the form into A to the C equals B. Here we have 10 as an A, and 100,000 for B, and 5 for C. So by plugging numbers into a formula, we have 10 to the 5th power equals 100,000. That's the answer. Write the equation in exponential form. Note, if you have a log base AB equals C, then you can change the form into the exponential form, which is A to the C power equals B. So here we have R for A, S for B, T for C. So we can rewrite the form into R to the Tth power equals S. And that's the answer. Write the equation in exponential form. Note that ln is written as log base e. So you can rewrite the ln 7.3891 equals 2 as log base e 7.3891 equals 2. Now, also note that if you have log A, B equals C, then that could be written as a to the cth power equals b. So here we have e for a, 7.3891 for b, and 2 for c. So using the formula, we have e to the second power equals 7.3891. Expand and simplify. Log base 5, 2x plus 7 cubed divided by 3x. First, we can use a quotient rule to separate the top and the bottom of the fraction. So we have log 5, 2x plus 7 cubed minus log base 5, 3x. Now, since we have exponent for the first term, we can bring down the exponent in front to have 3 log base 5, 2x plus 7. And for the second term, since we have 3 times x, we can separate 3 and x into 2 pieces. So we have minus parentheses log base 5 3 plus log base 5 x. Make sure you put the parentheses around these two terms because we have a negative in front that will affect the signs in the middle after we distribute the negative. So the final answer will be 3 log base 5 2x plus 7 minus log 5 3 minus log base 5x. Expand and simplify. Log base 4, 4 minus x over 3 squared. First, since we have a square term, we're going to take 2 down in front of the log. So we have 2 log base 4, 4 minus x over 3. Then we can use the quotient rule to separate the top and the bottom. So we have 2 log 4 times 4 minus x, 2 log 4, 4 minus x, minus 2 log 4, 3. And that's the answer. Expand and simplify. Log 4, square root of 3 times cube root of 10y divided by z to the 10th power. First, we're going to use a quotient rule to separate the top and the bottom. So log 4 square root of 3 times the cube root of 10y minus log base 4 z to the 10th power. Now notice that since we have a multiplication between two factors, we're going to separate them with using an addition sign. So log base 4 radical 3 plus log base 4 the cube root of 10y minus log base 4 z to the 10th power. Now we're going to rewrite the radical in terms of exponents. So we have log base 4 3 to the 1/2 plus log base 4 10y to the 1/3 minus log base 4 z to the 10th power. Finally, we're going to bring down the exponents in front of each log. So we have 1/2 log base 4(3) plus 1/3 log 4 10y minus 10 log base 4g. Now also notice that we have 10 times y, so we can separate them with using an addition sign as well. So the final answer will be 1/2 log base 4(3) plus 1/3 log base 410 plus 1/3 log base 4y minus 10 log 4z. This will be the final answer. Write as a single logarithm 2 log base 5t plus 5 log base 5t minus 6 minus log base 5t minus 7. First, we're going to take care of the numbers in front of each log. I'm going to bring up 2, 5 on top of t and t minus 6. So we have log base 5t squared plus log t minus 6 to the 5th power minus log 5t minus 7. Then we're going to use a product rule and quotient rule. We have log 5t squared times t minus 6 to the 5th minus log 5t minus 7. I just use the product rule. Then we can use the quotient rule. So we have log base 5 t squared times t minus 6 to the 5th power over t minus 7. And that's the answer. Write as a single logarithm 5 log base 7x plus 3 plus 2 log base 7x minus 1 minus 1/2 log base 7x. First, we're going to take care of the numbers in front of each log. So we have log base 7x plus 3 to the 5th power plus log base 7x minus 1 second minus log base 7x to the 1/2. Then, with using the product rule, we have log 7x plus 3 to the 5th power times x minus 1 squared minus log base 7x to the 1/2. Then we can use a quotient rule to have log base 7x plus 3 to the 5th power times x minus 1 squared over x to the 1/2. However, we can change the exponential form into a radical, so the answer will be the square root of x. Solve. Log x plus log 4 equals 2. On the left-hand side, we can combine these two logs with using a product rule. So we have log x times 4 equals 2, which is log 4x equals 2. If you don't see any base, it means we have base 10. So we can change the log form into an exponential form. So we have 10 squared equals 4x. Just note that log ABC is the same as a to the 5th power equals b. So 100 equals 4x. So by dividing both sides by 4, we get x equals 25. Solve. Log 2x plus 1 plus log 4 equals log 7x plus 8. First, we can combine the left-hand side terms by using the product rule. So log 2x plus 1 times 4 equals log 7x plus 8. Since we have one log on each side, we can drop logs, so we have 4 times 2x plus 1 equals 7x plus 8. By distributing, we have 8x plus 4 equals 7x plus 8. By subtracting 7x from both sides, we get x plus 4 equals 8. So the x equals 4. Solve. ln x plus 4 minus ln x equals ln x plus 1. First, we can rewrite the left-hand side with using the quotient rule. So ln x plus 4 over x equals ln x plus 1. Since we have one ln on each side, we can drop them. So we have x plus 4 over x equals x plus 1. X plus 1 is really x plus 1 over 1. So by using a cross multiplication method, we have x plus 4 equals x times x plus 1. So x plus 4 equals x squared plus x. So by subtracting x and 4 from both sides, you have x squared minus 4 equals 0. By factoring the left-hand side, we have x plus 2 times x minus 2 equals 0. So x equals either negative 2 or 2. Now, we have to check our answer. If x is negative 2, then ln x is going to be a negative. X has to be a positive number. Negative 2 cannot be the answer. So the answer will be just 2. Make sure that inside the parentheses, x plus 4, x, and x plus 1 are all positive numbers after you substitute your answer. Solve. Log base 2x plus log base 2x minus 1 equals 1. First, we can combine the left terms by using a product rule. So log 2 x times x minus 1 equals 1. And by using the exponential form, we have 2 to the first power equals x times x minus 1. So 2 equals x squared minus x. By subtracting 2 from both sides, we have x squared minus x minus 2 equals 0. By factoring the left-hand side, we get x plus 1 times x minus 2 equals 0. So x equals either negative 1 or 2. Now, we have to check that x and x minus 1 must be a positive number. So, if x is negative 1, then the first log will go negative, so you cannot have that. So if x equals 2, both x and x minus 1 will be positive numbers, so the answer will be just 2. Solve and give exact answer. 3 to the x power equals 243. 203 to be divided into 3 times 81. 81 can be written as 9 times 9. 9 times 9 is 3 times 3 times 3 times 3. So you can rewrite 243 with 3 to the 5th power equals 3x. Now since we have the same base, the exponents must be true, so the answer equals x equals 5. Solve and give exact answer. 4 to the x power equals 9 to the x minus 2. Since we cannot make the bases the same, we have to use the ln method. So first, we're going to take ln on both sides. When you take ln on both sides, the exponent drops in front. So we have x ln 4 equals x minus 2 ln 9. So x ln 4 equals x ln 9 minus 2 ln 9. By subtracting x ln 9 from both sides, we have x ln 4 minus x ln 9 equals 2 ln 9. By factoring out ln x, we have x times ln 4 minus ln 9. That is 2 ln 9. So by dividing both sides by ln 4 minus ln 9, we get the answer 2 ln 9 over ln 4 minus ln 9. That's the answer. Solve and give exact answer. 5 to the x power equals 125. Now 125 could be divided into 5 times 25, and 25 could be divided into 5 and 5. So we can rewrite the 2125 into 5 cubed. Since bases are the same, exponents must be the same. So the answer will be x equals 3. Solve and give exact answer. 64 to the x power equals 4 to the 4x plus 1. Notice that 64 could be written as 8 times 4, 8 times 8. That could be written as 4 times 2 times 4 times 2. So basically we have 4 times 2 times 4 times 2, which is same as 4 times 4 times 4. So 64 is really 4 cubed. So you can rewrite the 64 as 4 to the 3x. That equals 4 to the 4x plus 1. Since bases are the same, exponents must be the same as well. So by subtracting 4x from both sides, we have negative x equals 1, so x must be negative 1. Solve and give exact answer. 3 to the x plus 4 equals 6 to the x power. Since we cannot make the same bases, we have to take ln on both sides. So we have ln 3 to the x plus 4 equals ln 6 to the x power. Then we can bring down the exponents. So we have x plus 4 times ln 3 equals x times ln 6. By distributing, we have x ln 3 plus 4 ln 3 equals x ln 6. By subtracting x ln 3 from both sides, we have 4 ln 3 equals x ln 6 minus x ln 3. Now we can factor the x on the right hand side, so we have x ln 6 minus ln 3, which is 4 ln 3. Finally, we can divide both sides by ln 6 minus ln 3, so the answer will be 4 ln 3 over ln 6 minus ln 3. Assume log base b2 equals a, log base b3 equals b, and log base b5 equals c. Evaluate log base b50. Notice that log base b50 could be written as log base b 5 times 10, which is same as 5 times 5 times 2, which is also same as 5 squared times 2. So by using the product rule, we get log base b 5 squared plus log base b2. And by bringing down the exponent, we have 2 log base b5 plus log base b2. But we were given that log base b5 equals c, and log base b2 equals a. So the answer will be 2 times c plus a. Assume that log base b2 equals a, log base b3 equals b, and log base b5 equals c. Evaluate log base b fifth root of 300. So log base b to the fifth root of 300 could be written as log base b 300 to 1/3. That could be written as 1/3 log base b 300. Now 300 is 3 times 100, which is same as 3 times 10 squared, which is same as 3 times 2 times 5 squared. So we have 3 times 2 squared times 5 squared for 300. So we have 1/3 times log base b 3 times 2 squared times 5 squared. Now we can use the product rule to split these three factors. So we have 1/3 log b 3 plus 1/3 log b 2 squared plus 1/3 log b 5 squared. So we have 1/3 log b3 plus, by bringing down the exponents in front, we have 2/3 log base b2 plus 2/3 log base b5. Now we know that log b3 will be b, and log base b2 will be a, and log base b5 will be c. So final answer is 1/3 b plus 2/3 a plus 2/3 c. Let me rewrite that on top. So our answer is 1/3 b plus 2/3 a plus 2/3 c. Solve. Log base 416 equals x. We can rewrite the log form into exponential form to have 4 to the x power equals 16. Now 4 to the x could be written as 2 to the 2x since 4 is 2 squared. 16 is 2 to the 4th power, so we have 2 to the 4th power on the right hand side. Since bases are the same, exponents must be the same. So 2x equals 4, so x must be 2. Solve. Log 9/27 equals x. We can rewrite the log form into exponential form, so we have 9 to the x power equals 27. Notice that 9 is 3 squared, so we can rewrite the left-hand side as 3 to the 2x and the right-hand side as 3 cubed. Since bases are the same, exponents are also the same. So we have 2x equals 3, which will give us x equals 3/2. Solve. 75 equals 100 times e to the negative 0.04x. First, we're going to divide both sides by 100. So we have 0.75 equals e to the negative 0.04x. Since we have x as an exponent, we're going to take a log on both sides. However, since we have e in our equation, we're going to take ln form of log. So we have ln 0.75 equals ln e to the negative 0.04x. So we can bring down the negative 0.04x in front, and we have ln e. However, ln e is the same as log base e, so it's just 1. So it disappears. So to find x, you're going to divide both sides by negative 0.04. So we have x equals approximately 7.192. So the x will be 7.192. If I'll invest $800 in a saving account earning interest at a rate of 6% compounded semi-annually, how long will it take for the $800 to grow to $2,400? So we have the formula A equals the principal times 1 plus R over N to the N T. We know the principal, which is 800, and 2,400 will be the amount we need after a certain years, and 1 plus R, which is 6%, so will be 0.06 in decimal, over N, which is the number of compounds, so will be the semi-annually, so will be twice a year, and to the 2t. So we're looking for t. So first, we're going to divide both sides by 800. So we have 3 equals 1 plus 0.06 over 2 to the 2t. Now, 1.03 equals 1 plus 0.06 divided by 2 will be 1.03 to the 2t. By taking log on both sides, we get log 3 equals 2t log 1.03. So finally, you just have to divide both sides by 2 log 1.03 to isolate t.